All right, so we talked about qualitative motion a little bit yesterday in terms of what happens in terms of describing what happens with a graph as you move away from a detector towards a detector. And today I know that it says N4, but I really need you to be at N5 page in your notes, which has a bunch of graphs in it, and we're going to talk about those in a second. But before we talk about those graphs and examples, I want to reiterate and go through which of the following graphs have a positive slope, which of the following graphs have a negative slope, and which of the following graphs have a zero slope. Take a second, pause the video, identify which ones have positive, negative, and zero, and then I will walk through the answers with you. So here we go. The first one is zero slope because the line is flat. The second one is positive, and the third one is positive. So, and the fourth one is negative because it's has the going down. The fifth one is positive. The sixth one is zero slope because it's flat. The seventh one is negative, and the eighth one is positive, is zero. And we spent a lot of time doing this already, so I feel pretty confident that you guys are good at identifying positive slope, negative slope, and zero slope. This right here, this statement here, and this statement here were the two statements that I had you write down at the end of the hour yesterday. Some of you chose to write it down, some of you chose to not write it down, so I'm asking you to write this down now. So on your N5 note packet or note sheet, there are 4 boxes that have graphs on them, and then if you go to the other side, there is blank space, and on that blank space I would like you to copy this down. So I will have you pause this for a second, and while you pause it, you can copy this down because you really need to have this information for your notes for tomorrow, for the rest of this unit. So pause it, and while you pause it, I'm going to begin to get ready to talk about it. So like we discussed yesterday, if an object is moving to the right, its position is increasing, and I want you to think of it as moving away from the motion detector like I demonstrated yesterday. And if the object is moving to the left, its position is decreasing, and I want you to think of this as moving towards the motion detector. So the number line below is the best way I could come up with to help you see that, maybe potentially. So if we're going to the right, we are increasing our number line, and if we're going to the left, we are decreasing our number line. And again, this is something we talked about yesterday, so now I want to talk a little bit more about the content for today, which in this case is the relationship between a position versus time graph. So this is displacement versus time graph, and a new concept that we're going to talk about, which is a velocity versus time graph. Okay, so to start off, we're going to talk about we're going to give a common description. We're going to use words to describe what's occurring in the scenario. So we have an object moving left at a constant velocity. And yesterday and today, we talked about the fact that if something is moving left, oops, that's not what I wanted. If something is moving left, it's moving towards the motion detector, and if it's moving towards the motion detector, it's going to have a negative slope, which that's not what I wanted, but that'll work. So it's going to have a negative slope. So here we have a negative slope because the object is moving at a constant velocity to the left or towards the origin. Okay, now, So if it has a negative slope, and if slope is equal to velocity, which we talked about earlier this week, then that means that it would have to have a negative velocity. And when I look at this graph right here, I have positive velocity and I have negative velocity. And then I have what would probably be considered zero velocity. So if that's my graph and I'm going to go ahead and identify that I have negative velocity, I'm going to draw a line that looks like this. So this line right here is indicating a negative velocity because of versus time, because of the negative slope from the displacement versus time graph that we started with before. And remember, displacement can also be known as distance. Okay, so that's the first one. That one was kind of easy. Our second example would be if an object stands still. So if the object is standing still, that means that it does not move. And we identified yesterday that if something does not move, it has zero velocity, so its slope would look something like that. And it doesn't matter. That line could have been up here. It could have been right in the middle. It doesn't matter. It just has zero velocity because I don't have any other information for it. So in this particular case, when I write the fact that we have zero slope on a distance, displacement versus time graph, how would I represent that on a velocity versus time graph? Well, if we talked about this before, we said this is positive and this is negative, right? That means that this line right down the middle has to be zero slope. So anytime something is standing still, we have to represent it on that line. Okay. Now, a couple of things to remember is that slope of a displacement versus time graph is the velocity of the object. So in this instance, zero slope means zero velocity. So zero slope equals zero velocity. Okay, so we had one with a negative slope, we had one with a zero slope. We're going to try one that's a little bit trickier. And I would like to point out that these dashed lines here, they're going to become important in a second, so don't worry about them too much, but we're going to talk about them in a minute. So now, here's the deal. In this scenario, first of all, this is a distance or displacement versus time graph, and this is a velocity versus time graph. Okay, and the description that we're going to be working off of is that the object moves right, then stops moving. Okay, so let's talk about a couple of things here. First of all, if it moves right, oops, that is not the one I wanted. Let's see, we would do this. If it moves right, that means that it's moving away from the origin or the detector. Okay? And so this dotted line right here is the point at which we are moving right until the object stops moving. So I would represent that with a line like this, up to that point. Then the object stops moving, and because the object stops moving, that would indicate that it would have a 0 slope. Whereas moving away from the origin means positive slope. So at this point, I'm going to draw a 0 slope. So this is my distance or displacement versus time graph. That's what it looks like. So when I want to draw that, I want to remember that I have a positive slope to this point, and from then on I have a 0 slope because the object is no longer moving. On a velocity versus time graph, if this is the positive slope and this is the negative slope, I would draw a positive slope to this point. Then I would have a 0 slope from this point forward. So, or not slope, sorry, velocity. So I'd have a positive velocity until the object stops moving, and then I would have 0 velocity when the object stops moving. So this is a combination of two different types of motion. It's not too bad, but I think that we can handle it. So now I've got one more example. And in this example, first of all, we're going to say that this is a distance or displacement versus time graph. This is my velocity versus time graph. And my description in this case is going to be the object moves right, then immediately moves left. Okay, so let's talk about this for a second. If something moves right, we think of that as moving away from the origin or detector. And if something moves left, we think of that as moving towards the origin or detector. So in this particular case, I'm going to draw my distance or displacement versus time graph like we did yesterday. So if we're moving right, that would give me a positive slope. So I'm going to draw that. And if we're moving left, that would give me a negative slope. So I would draw this. Okay? So to this point, I have a positive slope. And after this point, I have a negative slope. Okay? So how would I represent that in my velocity versus time graph? Well, if this is the positive part of the velocity versus time graph, and this is the negative part of the velocity versus time graph, I would draw my positive slope to this point, and I would draw my my positive velocity to this point, and my negative velocity to this point. So here's a representation of my positive velocity. And here's a representation of my negative velocity. And so that's how we translate distance or displacement versus time graphs to velocity versus time graphs. So, so your homework tonight is to complete worksheet 5, and I believe it's a two-sider. And we will discuss the answers to this on, let's see, we'll discuss the answers to this on Thursday. Good luck, and we'll talk to you Thursday.